do, all right, there we go. So what we're gonna do is we look at complex circuits. We'll start really nice and simple. We'll have one resistor in series with these two additional resistors that are parallel to the circuit. So we have R1, R2, R3, and the power source. Power source, I'll give it 120 volts. R1, R2, R3. Let's do 10 ohms, 15 ohms, 4 ohms. Okay. Your goal is to be able to fill out this chart, because once you fill out this chart, that's when on the WebAssign you just walk through and you punch in the numbers on everything else. 4, 10, 15, 120 volts. Okay, that's your given. Now, the question is, well, how do I get the total resistance of the circuit? It's not series. I can't just go 1 plus 2 plus 3. It's not parallel because R1 is a series of everything. So what we have to do, right, 4, 10, and 15. All right. 4, 10, 15. If I think about this on my gravity style analogy, where here's 120 and here's 0. What's going to happen is you have a ladder R1 that takes you down, and then from R1 you have two options. You can go down 2 or 3. Okay, so this would be 1, 2, 3. So if you're standing here and you want to get to the ground, you don't have a choice but to take R1. Okay, 2 and 3, that's a choice. So what we can say is R1 is series with everything. Okay. So things that's going to mean is it's going to have the total current, just like the battery. R2 and 3 are parallels. So R2 and R3 are going to have the same voltage as each other because voltage is your electric height. So whether I take path 2 or path 3, I got to drop the same amount. So as far as the circuit's concerned, this branch here, 1 over 10, 1 over 15, 1 over R. You grab a calculator. 1 over 10 plus 1 over 15. That's 0.16 repeating equals 1 over R. So if I do the reciprocal, I get 6 ohms. Effectively, as far as the battery is concerned, the battery wouldn't do anything different if the circuit looked like this. 4 ohms, 6 ohms. Okay. If I chop this entire parallel branch out and put a 6 ohm resistor in its place, the battery would just keep on doing what it's been doing. It would generate the same amount of power with the same current, same voltage supplied, just keep on doing what it's doing. This is series 4 and 6, that's 10. So the total resistance of this circuit is 10. 10 ohms. 4 and a 6. Question. Okay. So now we come back here I'm going to do very similar things that we did before. Let's get that current dealt with. V equals IR, 120 equals I by 10. The total current's 12. You want to get total power P equals IV. 12 times 120 is 1440. We can also do the total power last, that doesn't matter. Now what happens is 12 amps leave the battery, and they don't have a choice. They have to go through R1. When they reach this point, they'll split. You can also trace it backwards to this point. So since R1's in series with everything, it has to have the entire current pass through it. All 12 amps will go through R1. And I found the total current. V equals IR, 120 equals I times 10, I is 12. Voltage. V equals IR. 12 by 4 is 48. And I find total R, that was all the way down here. I'll come back to that after. All right, so R1 has consumed 48 volts. Now, the way the circuit works, this line's 120 volts. This line is 0 volts. And I know that because the battery takes 0 volts and it raises it to 120. So I can have 120 on one side of it and 0 on the other. And voltage is established across the line. Last class, when we talked about parallel circuits, made it a point to highlight that unless you cross a battery or a resistor, your voltage does not change. So I got 120 volts right here. And I do cross a resistor, R1. Upon crossing R1, I'm going to lose 48 volts. So let's cross R1 and lose 48 volts. Crossing R1, losing 48 volts, that leaves me with 72 volts. So I have 72 volts before R2 and 0 afterward. That means it burns 78. I'm sorry, 72. R3, I got 72 before, I got 0 after. It burns 72. 72, 72. Let me show you my gravity analogy. That means this ladder takes you down 48 down to 72. So you're at a height of 72 here, you're at 72 here, you're at 72 here. You go down 72, you're at 0. Go down 72, you're at 0. You've reached the ground. Up here at the top of this ladder, you're at 120. Okay. V equals IR. All right, so 72 over 10, that's 7.2. 72 over 15, that's 4.8. So what's happened with the current, if I zoom in here, 12 amps, 12 amps came into this intersection, all right? 7.2 amps went this way, which means 4.8 amps went this way. That makes sense. All right. Finish off by getting power. 48 by 12. 576. 72 by 7.2, 518. 72 by 4.8, 346. 576 plus 518 plus 346, it came out to exactly 1440.